So now we're getting into section 5.5, the definite integral. This is a very important vocabulary word. The definite integral is the integral now that we'll have numeric values from a to b of a function f of x is defined to be the area under the curve from a to b. So the definite integral from a to b, and remember this is just sigma notation for area under curve from a to b. So this is how we will identify what geometrically a definite integral means. So more vocabulary, a and b. A is the lower limit of integration, b is the upper limit of integration, and f of x is called the integrand. So these are just some vocabulary words to connect with the definite integral. So if a function is continuous over that function from a to b, then f is integrable on that closed interval, and the net signed area between that graph is given by the definite integral. So let's get into an example here. So keeping in mind as we get into these examples, all of the area problems from the previous sections could also be defined as definite integrals. Let's show you what I mean. So here the function that we're focusing on is x from -2 to 4. So this is really saying find the area under f of x equals x over the interval from -2 to 4. That is how we read this definite integral. So let's convert it to area and find it. So what does x look like from -2 to 4? It starts here. 1, 2, 3, 4. So we are looking for this area, net area, under the curve. So just by drawing this, I can see that my answer will be positive. So this negative area, so this integral, so the integral from -2 to 4 of x dx equals this area, which is -1/2 times base times height times 2 times 2, plus the positive area of this triangle, 1/2 base times height times 4 times 4. So this definite integral equals -2 plus 8 or equals 6. So this definite integral from -2 to 4 is really going to be 6. Geometrically, that is the net area under the curve. Let's try another one.